Welcome to the Nature Club monthly Zoom meeting of December 22nd, 2020. I'm Bill Blodgett, president of the Nature Club. Our speaker today is John Jenkinson. His topic is living in Alaska, earthquakes, volcanoes, and more. Well, Alaska is 2.2 times the size of Texas, and the continental U.S. is 5.2 times larger than Alaska. So Alaska is quite big, as you all know. And here are the depictions of the various mountain ranges. As you can see, they're pretty extensive.
Uh-oh, did he freeze up on us?
Yes, I believe so. So this shows all of the different volcanic activity in Alaska. And we'll go on to the next slide. Okay, and we'll get to talk about John, because he was born and raised here in Texas, and he's like so many of us, he hates cold weather. So he joined, oh, there, John, he's back, Bill's back.
Yeah, well, that previous one showed the volcanoes and the Aleutian Trench. About our speaker, John Jenkinson. John was born and raised in Texas. Consequently, John disliked cold weather. After joining Big Oil, he and his family were moved to Colorado, London, then Alaska, where they lived for 24 years. After moving to Sun City, John keeps busy with teaching at Senior University and the Sun City Computer Club with topics in cybersecurity and Windows. At a Geology SIG presentation last year, he presented oil and gas development on the North Slope, Alaska. John holds degrees in physics and mathematics from UT Arlington and computer science from UT Dallas. John, you've got it.
Okay, I will do a stop share. Okay, John, you can go on and start yours up now, sir.
Okay, can you hear me?
Yes. Yes, and we can see you.
See the slide?
Yes.
So, yeah, living in Alaska, earthquakes, volcanoes, and more, the more is restricted to geology functions, because initially, when I set this up, I was going to present to the Geology SIG. So, and I'm not going to cover geography, but really narrow the scope to geology and not do wildlife and some other things that I think would be a separate presentation. So this is from Wikipedia. It's about geology. I was a major in science in college, and I never could figure out what those geologists were doing, pounding on rocks and those kind of things. And then after joining Big Oil, and at the time, this was in the early 80s, all they seemed to be doing was coloring seismic sections with colored pencils. And, you know, later I got a real awakening as just to how involved geology, especially for oil and gas exploration, is. So I have a great respect now for geology. So the topics in geology I want to cover in this presentation: volcanoes, earthquakes, glaciers. So far, we don't have any of those in Texas, so it is unique. Permafrost, yeah, we don't have that either. Northern lights, maybe sometimes. Avalanche, the Arctic Circle, tsunamis, and mining. And in the last slide I'm going to cut through in, because it's sort of an interesting aspect, is the geological weather influences that we exist here and in Alaska. So volcanoes, the Alaska Volcano Observatory, had by the University of Alaska, has 26 cams watching the active volcanoes in and around Alaska. And there's 15 being monitored with video cameras. It's in the Pacific Ring of Fire, and the first, one of the slides that Bill showed. Alaska has 80% of US volcanoes and 10% of all of those on Earth. So we have a lot. So Mount Tanakudla, yeah, erupted in 2012, and 700 feet of ash in 40 square miles of area. That's a lot of mass. The volcanic explosive index goes up to 7. This was rated at a 6. 100,000 foot ash cloud. 3 days later, it drifted over Seattle, and eventually that ash migrated across the ocean to Africa. Alaska has average of 1 eruption per year. Mount Spur in 1992 and Mount Redoubt in 1990 and 2009. This is a picture of the volcanoes that are near Anchorage. Anchorage is here, up Cook Inlet. These are usually right across the inlet. Cook had Turnagain Arm here, Kenai Peninsula. Redoubt volcano, it was a lot. So Redoubt, in 1778, Captain Cook was searching for the Northwest Passage, and he noticed the volcano that was later renamed to be Redoubt. In 1881, native hunters reported of that volcano eruption. In 1902, for almost 6 months, Redoubt erupted. 150-mile radius of ash and lava. That's, you know, here to Dallas as a radius. In 1989 and 1990, again, eruption for 6 months. This resulted in sudden snowmelt, pyroclastic flows, lahars, lots of lahars, and acoustic that spawned the University of Alaska to develop acoustic flow monitors to detect these lahars. As you can see from the area of Alaska, there's a lot of area to be covered, and Alaska study of volcanoes want to know when volcanoes might be erupting that were not near populous areas and might go undetected. A 747-400 KLM airliner actually thought that they could fly through the ash cloud. They thought wrong and lost all 4 engines. Luckily, they were able to descend and get them started and then land safely back at Anchorage Airport. But since then, the FAA, when volcanoes go off in anywhere in the world, it's Iceland, been a couple of volcanoes, but the ones that erupt in and around Anchorage, when they erupt, there's no flights in or out. Loss estimates, $160 million, second costliest in US history. And then again, on March 22nd, 2009, I had a friend and a private plane, and we went, had some clearance to fly around the cone of Redoubt. And it's really spectacular, you know, in a private plane, staring down the crater. And at the time it was venting steam, but not erupting, luckily. This is that volcano from space. Interesting. This is that volcano not from space. So Mount Spur, that interesting private story. When Mount Spur erupted, I was actually on a deep sea fishing expedition quite a ways from Anchorage. The wife and kids were home alone, and all of a sudden, you know, living in Texas, that was new to them. Debris avalanche 15 miles, 100-meter boulder was actually expelled as an eruption of Mount Spur. This is pictures of Spur. On the right-hand side, you can see a lot of people lining the inlet. This is near Anchorage, watching the eruption. This is ash, and the picture on the left doesn't really indicate how much ash was actually hit the municipality of Anchorage. On the right, you can see some of the downtown buildings with Mount Spur still spewing ash in the background. The problem with ash is, you know, we can scrape it off our roofs, which I did quite a few times, and you can sweep it off the sidewalks, but then what? You know, it's very pervasive. It's very conductive, you know, so you don't want electronics inhaling any of this ash. It's very, very fine powder, so it makes almost a cement. When it gets wet, it's just a real mess to contend with. Sort of a update to our current situation. You know, people were with respiratory problems were really encouraged to wear masks. That parking lot of the tire store, that's not snow, that's ash. Sort of a moment. This is actually inside an ice cave looking out at the northern lights. And you can see the refractions, you can see the stars, you know, just a really picture in my view. So water, 34,000 miles of coastline, surrounding all three sides of Alaska, 3 million lakes, 100,000 glaciers. 50% of all glacier ice on the planet is in Alaska. These lakes and waterways are used for subsistence. The natives do that for catching salmon, and when caribou and others come to drink water for subsistence. Remote locations limit dam viability. So yeah, we have lots of lakes and rivers, but getting equipment there to dam up those rivers to harvest electrical power is just not viable with the real locations. Climatic regions, they're the Arctic, the transitional, the continental, and maritime. So we have quite a few regions. Boar tide, one of the biggest boar tides in the world actually comes up Turnagain Arm, and it's been measured up to 35 feet. It's a real interesting aspect to go up on the hillside in Turnagain Arm when the boar tide comes through, and it looks like, you know, a wave on Hawaii that the surfers use. And there are some people that actually go out and surf these boar tides. So it's a really interesting thing to witness. And then ice flows. There's a season in Alaska called breakup, when the ice starts melting. It starts flowing down the rivers to get to the ocean. It's very unique. The Alaska Pollutant Discharge Elimination System is put in place to protect the rivers and streams. It's just a vital part of Alaska and the rest of the world as well. Alaska salmon, you know, those kind of things need their refuge protected. It's lately determined that salmon are actually bringing PCBs, one of the plastic compositions, back from their time in the ocean. Alaska spawn go out into the seawater and live for a couple of years, and then return up to freshwater back to where they were spawned from. Right outside of Anchorage, there's a fish ladder, and you know, when salmon start spawning or coming back upriver, it's really interesting to see these fish that are, you know, 18, 12 inches long, jumping 10 or 15 feet up a ocean or water ladder. Ice flows can be damaging. It erodes the banks of the rivers. This is another picture. This is the Alaska pipeline going across the tundra there with Mount Forker and Denali in the background. The two mountains there are sort of a unique thing in that have a lot of elevation, and a lot of that elevation is in the relief. Other high mountain ranges or peaks around the world usually are part of a range. So, you know, they don't have the relief going by. Driving by or taking a railroad trip and passing by Denali it's awe-inspiring. Earthquakes, you know, probably all heard about the 1964 Good Friday earthquake and Prince William Sound. They didn't have much monitoring, but they estimate the Richter scale magnitude was 9.2. The Space Needle in Seattle wobbled. It was registered in all but 3 states. Caused a lot of damage, was from tsunamis and landslides after the quake. The coastal forests turned to sea, were now inundated with seawater, so that it killed a large section of forest. The Anchorage Business District dropped 9 feet in elevation. Valdez had a 200-foot high tsunami. Tsunami is caused by earthquakes, and it causes disturbance in the ocean, and it causes a wave. And in this case, the wave was measured at 200 feet. Valdez was completely destroyed, had to be rebuilt. The North American plate overrode the Pacific plate, which caused the quake. And the BP building was in Midtown, and it was originally designed to be 15 stories long, but they cut it back to 13. And when they were building it, they actually had 5-foot concrete rollers that the foundation sits on. And I did quite a few years at the BP building. And when an earthquake came through, the building shifted side to side because it was on those rollers. And there were a lot of earthquakes. This is a picture of the forest that had the seawater get into the roots and, brought it up into the tree and killed the trees. So July 22nd, 2020, a 7.8 quake with a light tsunami. Every 15 minutes on average, there's an earthquake felt in Alaska. Of course, Alaska has a lot of area, so that, maybe that's not surprising. Living in the BP building and working for Big Oil, we had a game every time we'd feel a quake. It was, how far away is it and what was the magnitude? And we got pretty good at predicting magnitudes and distance. And then November 30th, 2018, a 7.0 hit Anchorage area. Pictures at the bottom show the devastation that can occur with earthquakes. This is a map from the earthquake monitoring system. The red dots are more intense, and the larger the dot, the stronger the quake. This is what causes quakes. It's called subduction. That's how it works. So this is another aha moment. This is what's called an ice rainbow or an ice cloud. It has to be really, really cold to see one of those, talking about 15 or 20 below. When it happens in the ice frost on the trees and the ice rainbow, it's just a spectacular sight to see, especially after growing up in Texas. This is a slide just showing how vast Alaska is and how complex the oil and gas that we go to Randall's and fill up our car, how much effort and time, and it's just amazing how much it takes to produce oil and gas and get it transported down and refined and end up at our filling station. You can see the Brooks Range in the background. This area is called the North Slope because it slopes down from the range into the Arctic Sea, the Chugach Sea. And all of these infrastructure that you see here, all of that had to be brought up by barge, by ocean sailing barge. And the ocean is not habitable by barge except for a few months in the summertime. So all this has to be done very quickly, and they get stuck. They have to sit there for 9 or 10 months waiting for the ice thaws. Glaciers are caused by snowfall that gets into snow melt, and then gravity squeezes those snowflakes and squeezes out the air. And that results in an absorption of red light. So these glaciers look blue. There's infrared stretching of the water molecule. Glaciers cause several geological things called plucking and abrasion. That's plucking is taking the soil from the side, and abrasion is rotating rocks. It's just, well, here's a picture. And this is the glacier flow. The lines that go parallel to the glacier are called moraines, and that's usually residue that's fallen down from the mountains on either side and then picked up and carried by the glaciers. And glaciers migrating takes a lot of time for the glaciers to come down the mountain. Unfortunately, with global warming and climate change, it's not taking much time for them to back up and go the other way, which is a real problem. This is Connect Glacier, flying over it. You know, if you were to be dropped in there, they probably couldn't rescue you. It's just an amazing sight to fly over this and see all the deep crevasses and ice. This is Denali and Foraker, 250 miles away from the downtown Anchorage. That's, you know, from here to the Oklahoma border, for example. You know, you can see, imagine in Texas seeing a mountain on the Oklahoma border. Permafrost. Permafrost, there's, what is it, 15 kinds, cold, ice rich, forced frost jacking, buried and special buried. It's a big problem because it has to be maintained, and we'll see why. So the depth of freezing has to be greater than the depth of thawing, and that with climate change, that's just not occurring anymore. It can be up to 2,000 feet in depth on the north portion of Alaska. Mining and research finds extinct fauna and flora. Ground cover and groundwater insulate permafrost, which is needed because melting it releases a lot of carbon dioxide and methane. That's another aspect of climate change that people aren't generally aware of, is with the melting of the glaciers and the melting of the permafrost, that's releasing a lot of greenhouse gases. Go up north and you'll find all the buildings up on pilings, and even the piping is above ground and then re-insulated because you don't want to dig a trench into the permafrost. And frost tees on the highways. If you've ever driven to Alaska, frost tees from permafrost cause it to be like a roller coaster ride. So some portions up and down the Alcan Highway in the interior of Alaska, it's like riding on a roller coaster with the frost tees, and you can't maintain much speed because of those frost tees. Northern Lights is spectacular. They can actually be heard. If you go outside during intense aurora activity, you can hear the crackling of the atmosphere of the radioactive ions interacting with the atmospheric particles, charged particles colliding with atmospheric gases. So the blue is based on nitrogen excitation, green is oxygen, and red is atomic oxygen, which are really spectacular. If you ever have the opportunity to fly into Alaska and fly out, if you could get in the back of the plane on the right-hand side, and then after takeoff, just look back out the window toward the north, and almost always you'll see really spectacular lights. In and around Anchorage, there's actually a phone tree that you subscribe to, and you get called if the aurora are really active. Photos don't really fully capture it. I've seen lots of pictures of the Northern Lights, and you know, actually being in Alaska and seeing that, it's really awe-inspiring. Speaking of awe-inspiring, this is the Northern Lights north of the Arctic Circle in wintertime. What does that really mean? That means there's no sunlight at all, 24 hours a day. All the light you see is from the aurora. There's even instances in this person's case that they actually could photograph a person's shadow with nothing but the Northern Lights. KP index is how they rate auroras. This is 0 to 9. This is an 8. Avalanche, we have rock slides and snow slides for avalanches. They build up a slab, then powder snow, wet snow, ice. All of this, you know, leads to inherent danger from avalanches. You probably heard of avalanches causing skiers to be lost. A lot of people are on the call list for trying to rescue people buried in avalanches in Alaska. This is the result of an avalanche. This was a cannon shot. They fire artillery up into loose snowpack, and that brings down the avalanche, and they clear it off the roads. And better to have it cleared by artillery than have it spontaneously come down and trap cars, which happens, you know, a couple times a year. The Arctic Circle, is that geography instead of geology? Yeah, maybe so, but it's really interesting, the midnight sun. I spent quite a few weeks up on the North Slope where it's above the Arctic Circle. And during summertime, which all except for one trip I've managed to arrange, sun never sets. And it's not, you know, like the sun rises in the east and sets in the west. That's not germane or relevant for, or accurate for being above the Arctic Circle. So this is a certificate that the wife got by going across the Arctic Circle. Let's go to tsunamis. There's the National Tsunami Warning Center that's in Palmer, Alaska, which is fairly deep into the interior, but not that far away from civilization. And National Oceanographic and Administrative Agency has deployed a lot of deep ocean assessment and reporting of tsunamis, so they can see tsunamis coming across the ocean. And they actually detected the 2011 Tohoku earthquake and tsunami that caused such damage in Japan. They were able to monitor that coming to the continental US and Alaska. Mining, gold, silver, zinc, you know, you name it, you can probably find it in Alaska. The BLM has records of 5,000 mining claims, 120 are active mines. A very interesting part of development of oil and gas on the North Slope is they use a lot of sand and gravel to build pads, to build roads and those kind of things. It's a legal requirement to document where you got this sand and gravel. And when we're not doing development on the North Slope anymore, all that sand and gravel has to be put back where it came from. And that is, you know, a lot of record keeping goes on as to, you know, where, and, you know, the amount of sand and gravel that's used to do development on the slope and other things, it's just really, really, really intensive and big. You may have heard of the Pebble Project. That's an effort to get a very large mine for gold, copper, molybdenum, and other minerals. And it's 200 river miles from Bristol Bay. And Bristol Bay is thought to be the most largest salmon spawning grounds in North America. This is some abandoned mines. It's Kennecott on the left and Independence Mine on the right. Getting to Kennecott is kind of a chore, but you can drive up to the Independence Mine. And lastly, geological weather influences. There's something called orographic lifting where it drains the moisture out of snow. We experienced this quite a bit. When we were living in Colorado, we were up above Denver, about 7,000 feet. And if you had a storm come across the mountains, orographic lifting really took a lot of moisture out of the snow. And the snow would be such powder that even with several feet on your car, if you could go out and kick it hard enough, all the snow would fall off. Whereas a front that came down from Canada and hit the Rockies, that was really, really heavy snow. You know, you would drive your car and there would be wheel wells, you're standing out. So wind funnels, it's really a problem in and around Alaska. When it, you saw in previous slide, it's kind of, there's mountains on each side of the inlet. So when the wind comes through there, it really gains a lot of speed. 60, 80, 90 mile an hour winds were not uncommon for those of us living up on the hillside outside of Alaska. Also, because of the midnight sun, very large vegetables are grown during the Alaska State Fair. Cabbages weigh, you know, a couple 100 pounds. Carrots are, you know, 10 or 15 pounds a piece. very quick to green. When snow starts falling in Anchorage, your lawn will be green, and then you'll have several feet of snow on it. And then when the snow melts, it's already green again, and which is not the case in my experience for Texas. So because of the location of Anchorage, there's one road north and one road south, and that is it. So, you know, if anything happens like this, it's very troublesome, I guess. You know, you have to make sure that you have used the restroom before you you commute to work, because you might be stuck in with several thousand of your friends for a couple of hours while they clear an avalanche or a wreck. So, you know, this is the two roads north and south. To get to the Kenai Peninsula for a lot of fishing grounds, you have to go this road all the way down the Cook Inlet until you can get across and back over to the peninsula. So with that, questions?
Well, we have a lot of questions. We have a lot of questions. And so let's start with, well, I just don't even know where to start. Somebody asked, did you hear that a major volcano just erupted on the big island of Hawaii?
Yes, yeah.
Was it
those are different kind of volcanoes eruptions. Those are lava flows as opposed to the explosions just shooting ash and boulders and debris.
Okay. Okay. Well, I'm sure y'all probably noticed that John does not have a camera. That's why you could not see him. I guess we should have told you that initially, but you figured it out, I'm sure. What did you like most about living in Alaska?
In my opinion, it was the whole experience. We were lucky enough to live on mid-hillside. So going to work, you know, you sort of went down the hill and then got on the freeway and ended up in Midtown. Going home was the exact opposite. You left Midtown traffic, and then you got on the hillside road. There was hardly any traffic, and you're just going up and up and up in elevation, and you can see the Cook Inlet with the ocean water. And you can imagine, you know, get in a canoe and I could be, you know, paddle to Hawaii with that access. And so you had the ocean and you had 8,000 feet mountains all within, you know, a mile or two of each other. It's just a really spectacular experience, especially, you know, not having any of that growing up in Texas. And the reduction of the glaciers in Alaska, it's really heartbreaking to see this. Exit Glacier, which is pretty close to us on the Kenai Peninsula going to Seward. When we first moved there, you could actually drive up to it. When we left, you had to hike about 5 miles to get back to the face of the Exit Glacier.
Wow, so they are disappearing. Is there a date when they expect that all of the glaciers will be gone, or? Well,
there's a lot of glacier activity are present still in Alaska. Mm-hmm. So yeah, a lot of them are receding and you know, losing mass. But most of those glaciers are several thousand feet thick, you know, at the base. So it will be a while, but it is accelerating. I mean, you know, climate change is taking its toll.
Well, someone is asking, what are LAHARs, L-A-H-A-R-S?
That's a geologic term that I had to look up as well. It's actually the debris flow through ravines, if you will. So, you know, when a volcano erupts, there's lots of ravines for the ash and other debris to flow down. And because of non-development in Alaska, most of those active volcanoes have a lot of ravines and other features, geologic features for the ash to flow down.
Somebody wondered, is it a state or a federal requirement as far as putting all the dirt and the land back where it came from?
Yeah, guess what? It's both.
It's both. Okay.
Yeah.
It's kind of just everybody says do it. Well, all those pictures, your slides were fantastic. You know, it made me think of Texas. Not really at all, but we have really, really enjoyed this. And does anyone have any additional questions? I'm trying to hope I answered, I asked all the questions that were listed here. If anyone has a question, just unmute yourself and you can go ahead and ask it. And then someone asked about the Bethlehem Star. And Mary Jane, did you have something on that one?
Yes. In fact, I had sent a private message to Carlos because he's been taking a lot of photographs of it. And it was really, really, really interesting to see it. Just some little quick information on it. Saturn and Jupiter had not been observed in over 800 years, and it's where they kind of came together, and they were named the Christmas star because they're closest to the Christmas holiday. But actually, history shows that this was actually what happened with the Star of Bethlehem, and they can prove that. I do have some pictures of it. Let me just see. Carlos, I don't know if you by any chance came on or if you heard me. Your pictures are so much better, but I'll do a quick share screen here so that you guys can see. Did y'all get to see it? Hopefully y'all all got a chance to see. Let's see here. Here it was. This was an actual video of it that they had taken, and I'm doing it up. Can y'all see this, Candy? Are you seeing the video?
Yes,
Okay.
it looks good.
Okay, I'm fixing to turn it on. And so I went out to look at it myself, and I wasn't real sure, but right here is one of the planets, and then right here, to me, it wasn't near as, I don't know, as much as I thought it was going to be. I was expecting it to be a lot more, and that's why I think some people had better shots of it. But that is what I saw, and then they had other pictures here where they were showing it. So even though, you know, what I heard in the news, it was back to back. It didn't quite look back to back to me. But does anybody have better information? Any of my astronomy guys here? You know, if you are, unmute yourself. Feel free to speak up.
I will unmute everybody if you would like. They can
Okay.
unmute themselves.
Great.
They want to talk.
Okay, well, I'm not hearing anything right now. So I'm thinking that what we need to do is maybe go back to Bill, but not before we tell John how much we appreciated his talk. It was really great. Thank you. I'm applauding too. I mean, I really enjoyed it.
Very good. I see right now Carlos is on. Carlos, if you want to unmute yourself, do you have a better picture than what I showed? He is one of the members of the photography club, and they were out there taking pictures. But Carlos, you are still muted. Oh, he's trying to talk, but he's still muted. Did you ask him to unmute?
I can ask him to unmute. I did that.
Oh, okay. Well, Carlos, buddy, sorry. We cannot.
Maybe we can see.
Can you hear me? Okay, good. I think it said I was blocked by the host, but now I'm not. Anyway, yeah, I don't have a picture right here, but we do have it in the photo club. If you go to the Sun City Photography Club, you'll see some of my pictures, and some other people have put it in there. And last night I got Saturn with its rings, and Jupiter and the 3 moons. You can go out there tonight and see it too. It won't be as close, but just look where the moon is and pretend that's the center of a clock. Look down towards the 5 o'clock position, and just about 5 degrees above the horizon, 10, 20 degrees above the horizon, depending when you look, you'll be able to see some bright areas, and take out your binoculars or telescopes. You'll be able to see it very, very nicely, I think. Yeah,
That's
I was
great.
disappointed as to how unbeautiful it looked. I mean, it's just like, okay, big deal. Congratulations.
Well, thank you for sharing that. And next month, when we have our first presentation, Larry Fowler is going to be presenting. Maybe if you're back, Carlos, you might have one of those and be able to share it with us. One of those pictures, we would enjoy that. Okay, well now we're going back to Bill. And this is going to be our last get together for 2020. And so Bill's going to be coming back to tell us what's going to be going on.
First of all, John, thank you so much for your interesting program on Alaska. The Nature Club gives special recognition and appreciation to Larry Fowler, who after many years of service is retiring as SIG leader of the Native Plant SIG. Larry has said he plans to remain active in the Sun City Nature Club. Thank you, Larry, for all that you have done for the Nature Club. We look forward to your Zoom presentation in January 2021.